A pitcher of water of 40 degrees Fahrenheit is placed into a 70-degree room. 1 hour later, the temperature had risen to 45 degrees. How long will it take for the temperature to rise to 60 degrees Fahrenheit? This is a version of Newton's law of cooling, except that in this case, the water temperature has risen, meaning that we're going to use the alternative Newton's law of cooling, which is the Newton's law of heating. The equation is the same, and that is T of T, which is the temperature at any time, is the surrounding or the ambient temperature, plus D sub 0, which is the difference between the initial temperature and the surrounding temperature, e raised to the negative kt. The variable in this equation is the capital T for temperature and the little t for time, in this case hour. We will need to find out what T sub S is, the surrounding temperature, D sub 0, which is the initial difference, not the initial temperature, but the difference in the temperature, and K is also the parameter. T sub S is the surrounding temperature or the ambient temperature, or the room temperature in this case, and it is 70 degrees. D sub 0 is the difference between the initial temperature of the water and the room temperature, which is T sub S. We were told that the initial temperature of the water is 40 degrees and the surrounding temperature, which is the room temperature, 70, e to the negative k t for now. And so we found a few substitutions. T of T is 70 plus negative 30 e to the negative kt. In order to use this question to solve for T when the temperature is 60 degrees, we still need to find out what K is. But that is where we would need to use the extra piece of information here. 1 hour later, the temperature has risen to 45 degrees Fahrenheit. And so in this case, even though we don't know what K is, but if we were to plug in 1 into T, 1 hour later, the right-hand side is 70 minus 30 e to the negative k, T is now 1. In this equation, we only have K left, and if we were to plug in 1, the temperature needs to be 45, so we set it equal to 45. To isolate K, we first rewrite this equation as 70 minus 30 e to the negative k times 1 is negative k, equals 45. To get to k, we need to get rid of 70. By subtracting 70 from both sides of the equation, the left-hand side is negative 30 e to the negative k, and the right-hand side, 45 minus 70, is a negative number, 25. E to the negative k is negative 25 over negative 30, which is 5 over 6. We then ln both sides of the equation. The left-hand side is ln of e to the negative k, and the right-hand side is ln of 5 over 6. Negative k is therefore ln of 5 over 6, so k is negative ln of 5 over 6. We can use a calculator to find out what negative of ln of 5 over 6 is, but it is a simple expression enough so that we just simply leave it for now. We update the equation. T of T is 70 minus 30 e to the negative of the negative canceled out. There's a negative sign in the formula, and there's a negative for k. But k is ln of 5 over 6, and then the variable is t. We are now ready to solve the problem and answer the question, how long, which is a question of little t, t for time in hour, it takes the temperature to rise to 60 degrees Fahrenheit. And so we don't know the time, but we need the temperature to be 60 at some point. The right hand side is 70 minus 30 e to the ln of 5 over 6 t. This equation has only one unknown t, so we will be able to find out what t is. We first subtract 70 from both sides of the equation to get negative 10 equals negative 30 e to the ln of 5 over 6t. 60 minus 70 is negative 10. We then divide by both sides by negative 30 to get rid of the constant multiple negative 30 in front of e to get 1/3 equals e ln of 5 over 6t. Keep in mind that we won't be able to cancel out this ELN even though they have the same base, because the t is being multiplied to the entire ln expression. And so if this looks confusing, we might just want to find out what this is in decimal and plug it in instead of using ln, but the answer in the final answer will be more accurate. To get to t, we would need to ln both sides of the equation because of the base e, and so we do ln and then ln. This time, this ln of e cancelled out, and it gives us ln of 1/3 equals ln of 5 over 6 times t, and so t is ln of 1 over 3 divided by ln of 5 over 6. We put this in a calculator and find out that this is 6.025685, which simply rounded to 6 hours. How long will it take for the temperature to rise to 60 degrees Fahrenheit? After 6 hours. If we were to cancel out the ELN at this point, we will end up with a negative time, which is not good. The reason why we kept writing ln is because we want to avoid any rounding error in the intermediate step. When we work with an exponential model, the result is very sensitive to the little change in the input.